Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. Some of the absolute value questions that are in the book. So I just want to go over them together with you and learn what kind of inferences we can make about these types of ratios on a number line. Starting with this one. For reference, these are on page 124 or 125 of my book. What we're looking at here is the absolute value of a ratio. You could think of it as the absolute value of x to the absolute value of y. And so the way to think about that is, I don't know which side of 0 x and y are on, but the one thing that I can say is that x is farther away from 0 than y is. Maybe one way to think about that is that the numerator overshadows the denominator, and that's why the ratio is greater than 1. I think it's worth mentioning that the ratio is definitely not going to be negative because we're looking at a ratio of absolute values. So I don't know if x is positive or negative. I don't know if y is positive or negative, but the ratio of their absolute values is definitely going to be positive, or 0 if x is 0. But when we're told that that ratio is greater than 1, that implies that the numerator overshadows the denominator. It's greater in absolute value, meaning it's farther away from 0. So if we were to draw x and y on a number line, we'd probably say something like this. Here's 0 in the center, and x is farther away from 0 than y is. So if y is somewhere inside this cloud, x has to be either to the left of that cloud or to the right of that cloud. You see how in my drawing, x is always farther away from 0 than y is. And that's really the inference that we can make about the positioning of x and y on the number line given this ratio. The function of absolute value is to make it irrelevant which side of 0 you're on, and then the only thing that still matters is how far from 0 you are. That's really the function that an absolute value performs. So the second question there was when the absolute value of the ratio is between 0 and 1. So that's effectively the exact opposite of the previous question. Right? Given that we know the absolute value can't be negative, well, then what are the options? Either it's between 0 and 1 or it's greater than 1. With two exceptions. It could be 0 if x is 0, and it could be 1 if x and y are equidistant from 0. Let me repeat that. So it's not just if x equals y that the ratio would be 1. It would also be 1 if x and y are on opposite sides of 0 but equally distanced from 0. Again, because we're looking at the absolute value of the ratio, not the ratio itself. The absolute value of the ratio renders it irrelevant which side of 0 they're on. So if x and y are equidistant from 0, whether they're on the same side of 0 or opposite sides of 0, the ratio would be 1. If x was at 0, the ratio would be 0. The fact that the ratio is between 0 and 1 implies that the denominator, I'm going to use that word again, overshadows. By that I just mean is farther away from 0, essentially. It's greater in terms of its magnitude than the numerator. Okay? So how would we draw that on a number line? We'd say, look, I don't know which side of 0 they're on, but I can tell that x is closer to 0 than y is. So if x lives somewhere here in that cloud, y is either to the left of that cloud or to the right of that cloud. Literally, the only inference we can make from the inequality here is that x is closer to 0 than y is, period. I don't know which side of 0 either of them is. I don't know how far from 0 either of them is individually, but I do know that x is closer to 0 than y is, and that's literally all I know. In this question, only the numerator has an absolute value on it. So now there's a little bit more information that we can extract from this inequality. Namely, we can say the following. I know that the ratio is positive because they told me that. And I know that the numerator is also positive. It could theoretically be 0, but then the inequality would be lying, because then the whole thing would be 0, and we're told that it's greater than 0. So I can infer that the numerator is positive, which means that the denominator must also be positive. So we can actually infer now which side of 0 y is on. We couldn't do that previously. In the previous two questions, we had no idea which side of 0 y is on, but now we can. Now we can say that y is definitely to the right of 0, but we cannot say which side of 0 x is on. Can we tell, though, who's closer to 0, x or y? The denominator overshadows the numerator, meaning that x is closer to 0 than y is. So if we drew this on a number line, again, we'd say here's 0. This time we'd put x in, I guess again, just like previous one, we'll say x is in some kind of cloud here around 0, and y is to the right of that cloud. So the difference between the previous question and this question is that in this question we have more information. We know for sure that y is to the right of that cloud and definitely not to the left of the cloud. So last one, we can tell for sure that this ratio is negative because we are told that it's less than -1, and everything to the left of -1 is negative. So we know the ratio is for sure negative, which means that x is for sure negative because the absolute value of something isn't negative. So the absolute value of y is not negative, and if the whole ratio is negative, x must be negative. So we can tell x is negative. Also, we see that this fraction, I guess you could just say, instead of using my language from earlier about the overshadowing, I mean, if you like that, go with it. It overshadows. But another way to think about it is, it's an improper fraction. So if you've forgotten what that means, any fraction where the numerator is greater than the denominator, like 7/3, would be considered an improper fraction, whereas 3/7 is a proper fraction. So another way to say it is, look, it's an improper fraction because it's more than 1 in absolute value, which means that x is farther away from 0 than y is. So if we were to draw a number line, we'd say here's 0 in the center, and we don't know which side of 0 y is in, but we know that y is the closer of the two. Y is closer to 0. And we know that x is negative, so x must be to the left of that cloud. So that's everything that we can infer from this inequality. I guess one way to say it is that if a ratio is more than 1 unit away from 0, then the numerator is farther away from 0 than the denominator is. Do you want me to repeat that?
Yes.
If a ratio is more than 1 unit away from 0, another way to say that is, if the absolute value of a ratio is greater than 1, then the numerator of that ratio must be farther away from 0 than the denominator is. And vice versa. If a ratio is less than 1 unit away from 0, then the denominator of that ratio is farther away from 0 than the numerator is.
Like, what would it look like if it was greater than -2? Like between -1 and -2? How would that limit us?
So if we knew this,
Yeah.
like that, we can still infer that x is farther away from 0 than y is. We can still infer that x is negative. We still don't know which side of 0 y is. But this inequality is a lot more informative than the original one because it gives us a narrower range. So there must be something more that we can infer from this one compared to the previous one. And what is it? Can anyone try to articulate for us what additional inference we can make in this case?
So x can't be more than twice as far from 0 as y is.
That would have been 100% accurate if I just add a little line there. Then what you said is perfect. Without that extra line, we have to modify what you said very slightly. We'll say y has to be, or excuse me, x can't be, x is farther away, but less than twice as far from 0 as y is. So x is farther away from 0 than y is, but less than twice as far from 0 as y is. So that's the additional inference. So if we were to draw it, we'd say, look.
And it's negative.
And it's negative. That's right. So we'd say, look, here's y in this cloud. X is definitely to the left of that cloud, but this time x doesn't go all the way to negative infinity. This time at most, there's going to be a limit there at 2y. 2 absolute, how should I say it? Negative 2 times absolute value y. It can go, it's going to be somewhere in this range. To the left of negative absolute value of y, but to the right of negative 2 times absolute value of y. So it's somewhere in here where this is negative absolute value of y, and there it's negative 2 times absolute value of y, and x is somewhere in between. We could write it out as algebraically. We'd say x is to the left of negative absolute value of y, and to the right of negative 2 times absolute value of y. Hey, I'm just going to interrupt my own video for a moment here. If you're finding value in this video, please let me know in the comments below, and give this video a thumbs up. It really motivates me to keep uploading a new video every day. Alright, back to the video. I want to try to build an analogous question to this one. Let's see if you can all go with me here. So imagine that we are talking about the percent salt in some saline solution. So saline solution means salt and water. So what percent of the mixture of the saline solution, what percent is salt? So imagine the question asks, is it at least 10% salt? So instead of talking about an employment rate, we're talking about percentage salt in a saline solution. And in that analogy, we'd say for statement 2 that this saline solution is the result of mixing two separate saline solutions, one of which has 20% salt and the other has 10% salt. So, because that's what statement 2 is describing, right? You're taking two different saline solutions, one of which is 20% salt, the other is 10% salt. You mix them together. Would the resulting saline solution have at least 10% salt? What do you think?
Yes.
Yeah, it's going to be some kind of weighted average, right? It'll be between 10% and 20%. Closer to 10% if there was a greater volume of the 10% saline solution, and closer to 20% if it was a greater volume of 20% saline solution. This modifier is something that people tend to kind of gloss over and not really, not digest properly. Right? This is an important modifier in the question. And notice how it's repeated in the statement that is sufficient on its own. I think one of the most important parts of this question is this part that I'm underlining here. That implies that we're looking at the sum of 6 different positive integers. And that sum is 75. And what I would do on my scratch paper to help myself think about this is I would draw 6 spaces, 6 horizontal lines like that, and then put a greater than sign in between each of them. So I'm arranging them in descending order from left to right. If it wasn't for that piece of text that I underlined, then I would have had a greater or equal sign. Greater or equal, greater or equal, greater or equal, greater or equal. So that's the distinction. And this is a visualization method that I developed after many, many times of making careless errors when the GMAT tells me there's these 5 different positive integers, and I would just miss the word different. I would miss the word different. In this case, it's not the word different. It's no 2 countries sent the same number of representatives, but that's the same thing as saying they're different numbers. I missed that word so many times, and then I developed this visualization method, and since then I haven't made that careless error. Because I ask myself, is it greater than, or is it greater or equal? And then I have to check, and then I see the word different. Okay. As I keep reading the question, actually let's also do this, so we know that the sum of all of these is 75. And let's call this A, because they're telling us that country A had the second greatest number. So that's A. And we want to know whether or not that number is less than 10. So the biggest number it could be for a no is 9. So up to 9 would be a no. From 10 and up would be a yes. So 9 and 10 is kind of the cutoff. Like the difference between a yes and a no falls right at the 9 versus 10. So I'm wondering, well, why don't I see whether A could be 9 and whether A could be 10. And if a statement allows both possibilities, then it's not sufficient. But if a statement only allows one of those possibilities, well, then it probably is sufficient. So that's kind of the strategy. And it's funny, earlier today I was talking about when it is appropriate to test cases. Well, here we go. Here is a situation where it is appropriate to test cases because there's a very limited number of possible cases to test. There's not an infinite number of possible cases. And we just want to see whether it's possible for A to have 9 and also for A to have 10. If it is, then we've proved insufficiency. Which statement do you all think I should start with?
B.
Absolutely. Yeah, we'll start with statement 2 because immediately we can see that it's not sufficient. It could be 10, it could be 9. So we can eliminate the answer choices that claim that statement 2 is sufficient on its own. Now with statement 1, we now know that this is 41. We know that that's 41. Is it still possible to have a 9 for country A? Well, 41 plus 9 is 50, so we would need to fit another 25 with numbers that get smaller and smaller. So can I get 25? Let me try. If I do 8 and 7, that's already 15. Can I get 10 more? Yeah, I could just do 6 and 4. As long as those numbers are getting smaller and smaller each time, we're good. And looks like it is possible for it to have 9. Now, what if I wanted it to have 10? Would that be possible as well? Well, yeah, I could just use the exact same numbers and just make this last one smaller by 1. I removed 1 from the last country and gave it to country A. So I've shown that, yes, country A could have 9 and it could have 10. And that eliminates answer choice A. And when I combine the statements, everything that I have here on my scratch paper still works. I can still have 41 followed by 98764, and I could still have 41 followed by 108763. And therefore the correct answer is E. So this is an example of a question where it's appropriate and necessary to test cases. Notice how I'm testing cases in a very thoughtful and strategic and organized fashion. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.